This is part 1 of section 4.1, graphing with a table. So today we're going to be graphing a linear equation using a table of values. So let's start off by just answering the question, what is a linear equation? So the word linear here, I want you to take a look real carefully. See how it says line in there? We're actually going to be graphing equations of lines. A very basic understanding of a linear equation is that it can have one or more variables, but the variables have to be raised to the first power. So here are some examples on the left-hand side here. 3x minus 7 equals 8. This is an equation that we've been solving, since chapter 3. 2a equals 10. That's still linear because everything is to the first power. This was x to the first power, a to the first power. And again, here's another equation that looks really similar to what we've been solving before. We see multiple x's, but all of them are always raised to the first power. And the last one here, we have two variables. But again, both variables here are raised to the first power. Now the list off to the right, these are not linear equations. And as you can see here, the only difference between the equation over here on the left and the equation over here on the right is the fact that this exponent here is not a 1. It's squared, 3x squared. So that automatically means it can't be a linear equation. So we see a couple more examples. Here we have 3a to the 4th power. So that's why this cannot be linear. And then in the bottom equation here, both our x and our y are not to the first power. So these are all examples of equations that are not linear, whereas on the left, these are all examples that are linear. So in today's lesson, what we're going to be doing is graphing linear equations with two variables, x and y. So all of our equations are going to look similar to this first example here. And we use a table of values in order to graph this linear equation. So again, remember we see the word line here. We're going to expect that we get a shape of a line. So we start our table with x values on the left. So here's an x column here. All of these values indicate what x is equal to. So we have -2, -1, 0, 1, and 2. This is a standard table. So we like to use -2 to 2. And for tomorrow, we're always going to use -2 to 2. Eventually, we're going to start seeing different table values. But for right now, we're going to use this standard table. Okay, so now that we know what our x values are, we have to figure out what y is equal to. Now we have this equation right here, y is equal to -3x plus 2. That is how y is defined. So what we're going to do is go ahead and plug in this x value. The first one is -2. We're going to go ahead and plug that in for the x that appears in this equation. So that's how we're going to figure out what y is equal to, because y is equal to -3 times x plus 2. So let's go ahead and plug that in, and I'm going to use different colors to kind of help us understand how to plug in the values. Alright, so I'm plugging in -2 in for the x, and I'll do that in purple. And I want to plug that into this equation here. It says y is equal to -3x plus 2. So -3 times x, which is now -2, because I'm plugging that right into the equation, right? I'm plugging it right in here for the x. Then I have to make sure I add 2. Do the rest of that, that's plus 2. So this is what's going to give me y. -3 times -2 plus 2. So when I type that in my calculator, I'll get 6 plus 2, and that gives me 8. I'm going to do this in a different color because this is what the y is equal to. Okay, so y here is equal to 8. So let me go ahead now, and I can rewrite this as an ordered pair. This is the x value, and now this is my y value. So if I write that, excuse me, as an ordered pair, I have the x is -2 and the y is 8. So I have the coordinate -2, 8. Okay, so now we're going to go ahead and we repeat that process. This time we use a different x value. Now our x value is -1. So again, we repeat this process. We're just going to plug it in for the x right here in the equation. So when I write this out and show the work, I'll write -3, and then I'm going to substitute x is -1 now. So times -1. Then plus 2, and when I put that in my calculator, -3 times -1 is +3, plus 2, and then I end up with +5. Alright, now, my ordered pair here, my x value is new, right? It's -1 now, and my y value is that red number here, it's 5. So now I have another point. So let's try this process again. This time we're going to plug in 0 for x. Again, 0 is going to get plugged in right here for the x. So I end up with -3 times 0, then plus 2. So negative 3 times 0, anything times 0 is always 0, right? Then plus 2 gives me 2. Now I have the coordinate, let's put it in parentheses here. The ordered pair is going to be 0 for the x value, and the y value is 2. Alright, we've got a new x value now to plug in. We've got x is equal to 1. Again, you're going to plug x equals 1 into the equation here for x. So, as I show the work here, it'll look like this, negative 3, now times 1, then plus 2. So negative 3 times 1 is negative 3, plus 2, and I'll get negative 1. When I rewrite these as coordinates, remember this number is the x value, so I have x is equal to 1, and the y value is what I have in red here, so negative 1. So I have the coordinate 1 comma negative 1. Alright, now our last value to plug in is x is equal to 2. So we're going to go ahead and plug that right back into the equation for x. So we have negative 3 times 2, and then plus 2. When I type this in my calculator, negative 3 times 2 is going to give me negative 6. Negative 6 plus 2 is going to give me negative 4. So I now have coordinates where the x value is 2 and the y value is negative 4. Alright, now that we have our table filled out and all of these points, we're actually going to go ahead and we're going to plot all of these points in our table. Okay? So let's go ahead and start with this first point, negative 2, 8. So I go left 2 and up 8. Plot my first point. That one's done. Second one, negative 1, 5. Go left 1 and up 5. Then the next one, 0, 2. So I stay on the x, or at the origin, and then I go up 2. That one's done. 1, negative 1. I'm going to go right 1, down 1. And my last point is 2, negative 4. So I go right 2 and down to negative 4. Okay, now when you're looking at these, you're going to use a ruler in class. I obviously can't use a ruler on the computer though, so I'm just going to try to draw this as straight as I can through those points. And then notice I'm putting arrows on the ends here because I could, if I want, continue to plug in more x values, which means I'll get more coordinates and more points. So this line actually goes forever and forever, right? A line is infinite. It's made up of an infinite number of points. So we're going to show that by always showing little arrows at the ends, okay? Now, one way you can kind of figure out if you maybe plotted a point wrong or if you have a table value that's wrong is, let's say one of my points was plotted all the way over here. Well, we never want to draw a line that looks like that, right? That would tell us, uh-oh, something's wrong. So if one of your points is way off course from all the other points, you might want to recheck your table or recheck that you plotted that point correctly, okay? So the very last thing we're going to fill out here is the bottom. And we're just going to try to re-emphasize this idea. The graph of a linear equation, which is what we've been trying to solve, right? A linear equation, the word line appears right in there, so it's always going to be a straight line when you graph a linear equation. Okay guys, that's the end of the lesson. I will see you guys in class tomorrow.